Hello everyone, welcome back. In this video, we will be discussing about the last problem of today's weekly contest, closest prime number in the range. The problem states that you are given two positive integers left and right, and you have to find out two integer num1 and num2. These two integers should satisfy all the following conditions. The conditions are num1 and num2 should lie between left and right, and num1 should be less than num2, right? Second condition is num1 and num2 are both prime numbers. And if there are more than one possible pairs for num1 and num2, you have to return the one which have the minimum value of their absolute difference, right? So let's take an example. Let's say left is 10, right is 19, right? So in this case, there are various possible values of num1 and num2. So one possible value can be 11, 13, and then 11, 19, or 11, 17. So all these are the valid possible value of num1 and num2 because it satisfies both these conditions, like 11, 13, 19, all are prime numbers, and they lie between left and right, and one of them is smaller than the other one, right? But as given in the problem, you have to return the one which have the minimum among all the pairs. So you can see there are two pairs which have the minimum absolute difference, 11, 13 and 17, 19, right? But it is also given that if the difference is same, then you have to return the one with the minimum value of num1. So among 11, 13 and 17, 19, we will be returning 11, 13, and hence 11, 13 is our answer, right? So hope the problem statement is clear. Now how to solve this? So these are the three conditions, right? Left, like nums1 and nums2 should lie between left and right, and one of them is actually lesser than the other one. They both are prime numbers, and their absolute difference should be the minimum one. So let so look at this one. Like the first two conditions are very easy to satisfy. This Look at this one, nums1 and nums2. Difference between them should be minimum, right? So if you, let's say, one of nums1 and nums2 is 3, right? So if one of them is 3 and you want minimum absolute difference, which one should be the other? If it is nums1, then nums2 should be 5 only, right? Similarly, if it is nums2, num1 should be 2 only, because if this is nums1 and you take, let's say, nums2 as 7, it doesn't make sense because this difference will always be greater than the difference that you will be getting if you are taking 5 as num2, right? So that's where our problem is now reduced. So we are given, let's say, first of all, you find the prime numbers, right? Because nums1 and nums2 both are prime numbers, so you just find a list of prime numbers. Now from this list of prime numbers, you can easily filter out the one which satisfies this condition, basically everything between left and right. Now once you satisfy these two conditions, the third condition what we have just shown is for a single, like for a particular value as nums1 and nums2, only thing that matters to us is the adjacent elements or the adjacent prime numbers. That's it, right? So let's just take a complete example, and that would just make things clear. So again, let's say, let's take this example only. Left is 10 and right is 19, right? So left is 10 and right is 19. So how exactly would you solve this? So first of all, let's just get rid of this. So left is 10 and right is 19. So you just start iterating from the left, right? These are the list of prime numbers, right? So you just started iterating from the left. You just see which range is applicable to you. So you will notice that this range is applicable to you, right? Now you want the exact pair. So you will try, okay, 11 is my nums1, because nums1 should be less than nums2, right? So the first one that you are taking is should always less than the second one. So that's where you will say, okay, 11 is my nums1. So as discussed, because of this condition, what would be the only value of num2? Only value of nums2 would be 13, right? So you'll see, okay, for 11 nums1, I'm getting 13 as nums2. So let me just find the difference and I will just store the difference and somewhere, right? Then I will try, okay, let's say this is my nums1. If this is my nums2, 17 would be this is my nums1, then 17 would be my nums2, right? Similarly, I will try 17 and 19. So basically, I'm trying every possible combination for nums1 and nums2. Like we are not trying 11 and 17 because we just have proved a while ago that if 11 is nums1, then because of the third condition, it only makes sense to take 13 as nums2, not anything after that, right? So that's where we'll just start with, we'll just find the range, and after finding the range, we'll just point our nums1 to that particular number and just keep on going rightwards and trying out every possible such value of nums1, right? So hope the solution makes sense. I would strongly encourage you to pause the video right away and try to code this solution yourself, because this is not that difficult. If you're not able to code it, feel free to come back and watch the video till the end. So this is the code. This is exactly similar to what we just discussed. We'll just find a list of primes, right? How to find a list of primes is a separate question. We'll come to that. We find a list of primes until 10 to the power 6. Why 10 to the power 6? Because the value of right is at most 10 to the power 6, right? So after finding the primes, we just iterate over it from left from 0 to n minus 1. So notice that we are not iterating up to n, because if this is my nums1, right, then I need something at nums2, right? So the next one should be my nums2. So that's where this 929 can never be nums1, because there is nothing after that, let's say. So after this, there is no nums2 at all, so there is no point in taking 29 as nums1 itself, right? So that's where I am just iterating up till n minus 1, right? Now while iterating, I am just checking if is current value and the next value are possible nums1 or nums2 or not. So with this condition just checks whether this condition, the first condition, is satisfied or not, right? So if this condition is satisfied, we will just find the difference between them and see if the difference is actually less than whatever difference we have found. If it is less than that, we will assign, we will assign that to our result and just uh, change our current difference as well. So notice that there is no equal to here. If it is because we want the first, if the difference is same, we want the one with the minimum value of nums1, right? So that's where there is no equal to here. If it is equals to, we will get the one with the maximum value of nums1. Okay, so that's basically a source implementation detail. So after you complete this loop, this diff would contain the exact difference between nums1 and nums2, and result would contain the value of nums1 and nums2. Now notice that I initialized everything with -1 and -1, and because it is given that if we are not able to find any such pair, we will have to return -1 and -1. So that's what we have done. Now coming to how to find primes. So finding out primes in a given range or up to a given number is very standard problem. I would encourage you to read about it in Wikipedia or any other articles. There are various good articles on that. In short, what we can do, we can just start iterating from left, like from 2 to n, because 1 is not a prime always. We are sure about that. So we'll just start from 2 to n, and we just mark out the factors of 2. So factors of 2 would be like 4, 6, 8, and so on, right? So we'll just mark out the factors of 2, and if if we have tried out everything before current integer, right? So if you have tried out, let's say you wanted to check whether 11 is prime or not. So you have marked out so for 11, what can be the factors? The factors can be everything before 11, right? So if we have marked all the factors of everything from 1 to 10, then 11 11 is 11 will not have any factor, right? So that's what we are checking. If we have initialized everything with j, so if 11 factor of, let's say 11 is still 11. It means there is no other number which claims that I am a factor of that for 11. So this loop basically says that J is claiming that J is a factor of K, because K comes as a multiple of J. So because of this, the value of K or the factor of K would be something which is not K. And if it is something which is not K, this condition would not be satisfied. So this condition, what is saying is, for J, no one before J claims that I am a factor of J. So hence I am a prime number, right? So that's what the logic is. Uh, Again, this is a standard problem. You can just, if you don't understand it, feel free to refer to any other articles. If you want me to create a video, feel free to post that in the comment section. I will be happy to do that. So yeah, that's it. If you have any doubts, please post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already. And I will see you in the next one. Thank you.